Hey everyone, welcome back. So in the last video, we have created our first single container pod where one pod run one container. But Kubernetes also support running multiple container inside the same pod. So in this video, we will cover what is multi-container pod, why and when do we use it, what is the sidecar pattern, and how container communicate inside a pod. And finally, we will also write a YAML file and we will run it on the Kubernetes cluster. So let's get started. So what is multi-container pod? A multi-container pod means one pod contains more than one container. All containers inside the pod share the same network. They can talk each other using a local host. They start and stop together and run on the same machine. Now, this does not mean you should always put multiple containers inside a pod. Most of the time, one pod means one container, and this is very standard. But sometimes two containers are closely related that makes sense to keep them together. And this is exactly where we use the multi-container pod. So let me give you a simple example. Think of a delivery truck. A truck has a driver whose main job is to drive and deliver the package. But sometimes truck also carry a helper who assist with loading, unloading and delivering the package. The driver is the main person and helper support the driver. They travel together in the same truck, share the same routes and work as a team. So in Kubernetes, truck is a pod, driver is your main application container, and the helper is the supporting container, which is also called as a sidecar. Now let's see the sidecar pattern. The most common use cases for the multi-container pod is the sidecar pattern. In the sidecar pattern, one container run your main application, another container run alongside it to support the main application. Now let's see the real example of the sidecar. A log collector containers that read the log from your application and send them to the central logging system. Second, a config reloader that watches your configuration change and update the application. A health checker that monitor your application and report the status. Your main application does not need to worry about any of the tasks and the sidecar handle them separately. This keep your main container clean and focus on the actual work, and we will see the hands-on on the third example. Now how sidecar communicate inside a pod. Now all containers inside the same pod share the same network namespace. That means they share the same IP address. They can communicate with each other using a local host. For example, if your main app run on port 80, the sidecar can reach it simply using localhost 80. No service, no external IP needed, just local host. So this is what makes multi-container pod more powerful. Now let's understand the YAML file that we are going to create. So in this example, the main container run on Nginx, our web application, and the sidecar container run BusyBox, which act as a health checker. And this sidecar will check the Nginx health every 10 seconds and print whether the application is healthy or not. This is the real world use cases. Your main container focus on serving the application and the sidecar monitor the applications. Now let's do the practical. So now let's open the killercoder.com, then click on the Kubernetes scenario. Select the Kubernetes playground or CKA playground and your Kubernetes live environment will be ready in few seconds. Wait for the environment to load. Once it loads, you will see the terminal with real Kubernetes cluster ready to use. So let's verify the cluster first. And to verify, we'll use command kubectl get node. And you should see your nodes are in ready state. So let's get started. And we will press -I to enter into the insert mode, and we'll copy the YAML file exactly shown below. Press escape and then type :wq and press enter and save and exit. Now let's verify the file which we have created. And to verify it, we will use cat command and file name. And the file looks correct. Now let's create the pod. And to create the pod, we will use kubectl apply -f and then file name. Our pod has been created. Now let's check the status. To check the status, we will use kubectl get pod. Now you can see the ready column is 2 by 2. This means both containers are running successfully inside a pod. So by checking the ready column, you can quickly tell this is multi-container pod. Now let's describe the pod. And to describe the pod, we will use kubectl describe pod and then pod name. And now let's scroll to the container sections. Now you will see both containers are listed separately. The main app and health container, each with their own image, port and state. This confirms both containers are running inside the same pod. Now let's check the log for the container. So in the single container pod, you just run kubectl logs and the pod name and you will see the logs. But in the multi-container pod, kubectl does not know which container log that you want. So you must tell Kubernetes by using -c flag followed by the container name. So to check the log for the main container, kubectl logs multi-container pod -c and then container name. And you will see Nginx startup log, and this confirms Nginx started successfully and ready to serve the traffic. Now let's check the logs for the health checker container. So kubectl logs -f, then multi-container pod -c and health check containers. And you'll see Sidecar is successfully reaching out to the Nginx main app using the localhost 80 at every 10 seconds. To go inside the main container, we will use kubectl exec -it main multi-container pod and then -c the main app and -f and bash. Now you are inside the Nginx container. Let's verify the Nginx. So to verify the Nginx, we will use curl localhost and you will see the Nginx default HTML response. Now let's exit from the container. Now let's go inside the health checker container, and to go inside the health checker container we will use command kubectl exec -it multi-container pod -c and health checker -sh. And to reach out to the main app from the sidecar container we can run this command, and you will see Nginx default HTML response here too. So this proved that health checker sidecar container can reach to the main app simply using a localhost because both containers share the same network inside the same pod. Now let's exit from the container and then let's delete the pod. To delete the pod, we will use command kubectl delete -f multi-container pod.yaml file. Our pod has been deleted. Now let's verify whether our pod has been deleted or not. So you should see no resource found in the default namespace and the pod has been deleted. So let's quickly recap. A multi-container pod runs more than one container inside the same pod. All containers share the same network and communicate via localhost. The sidecar pattern uses helper container for all tasks like logging, monitoring, and health check, while main container run the applications. Ready column 2 by 2 show when two containers running inside the same pod. Now let's see some of the useful command that we can use for the multi-container pod. First, we have a kubectl get pod. This command lists all the pod running in the default namespace. Second, kubectl logs pod name -c container name. This command shows logs of the specific container inside a pod. Third, kubectl logs -f pod name -c container name. This command displays the live streaming log of the specific container. Fourth, kubectl exec -it pod name -c container name -f and bash. And this command opens the shell for the specific container to run the commands. Fifth, kubectl describe pod name, and this command shows the detailed information about the pod and all container inside it. And the last, we have a kubectl delete -f file name, and this command delete the Kubernetes resources defined in the YAML file. So that's all everything about the multi-container pod, and in the next video we will learn about the init container. Thanks for watching and I will see you in next video.